Welcome. In this session on natural deduction, we'll explore satisfiability. To do this, let's consider a formula. Actually, let's consider the negation of a formula, and we'll use the well-formed formula notation. Our question here is, does the semantic entailment from no premises of this formula hold? That is, what we're asking is the negation of the formula a tautology? And this is an example within our metalogic of a statement that is true or it's not true. So if this is a tautology, then we can make a very clear statement about it. What we can say is that for all models, the model semantically entails the negation of the formula. This is simply a mathematical way of writing what we had already established in a previous session, which is what it means to be a tautology. Something is a tautology if it evaluates to true under every possible model. So if this semantic entailment does not hold, then we can say that the negation of this is true. That is, it's false that for every model, the model semantically entails the negation of the formula that we're looking at. This is a metalogical statement. That is, it's a statement about the logic. We're saying if we scan over all possible models and it's not true that every model semantically entails the negation of that formula, then that means that the negation of that formula is not a tautology. Now, we can use some ordinary mathematical reasoning. Let's recall something about basic mathematics. If we say for all x, a property of x holds, and we say that that's not true, that means that there exists a counterexample. And how we would do this in this metalogical statement is we would say that means that there exists a model such that it's false that that model entails the negation of our formula. Now, let's consider what this means. If it's false that the model entails the negation of the formula, then that's true that the model entails the formula. That is, we can distribute this across. So we'll say this is the same, and I'll put parenthetically in metalogic as we're saying that there exists a model such that the model semantically entails the formula. And what we've established then is we have a metalogical statement here. We're saying that if the negation of a formula is a tautology, then the negation of that formula is true for all models, and that means that the original formula cannot be satisfied because its negation is satisfied. On the other hand, if there is at least one model such that the model does not semantically entail the negation, then that means that that model satisfies this. So we now, so how can we use this? Well, what we might try is we could try search all models for a counterexample. And let's put that in quotes because it's not truly a counterexample, but counterexample is a good way to think of it. So we could try doing that. So a conundrum in this is that if we have n atoms, there are 2 to the n rows in the truth table. And we don't have to make n very large before 2 to the n exceeds the number of protons in the known universe. That is, before n does not have to be very large before the number of rows in the truth table is practically not worth computing. So there is a better way, and that better way is, instead of looking at the 2 to the n rows in the truth table, which would be the semantic way to approach this problem, to look at the satisfiability, what we'll instead do is look at the n atoms in a formula.